So I just wanted to bring that idea of the friction here. Mu be the coefficient of friction between the rod PQ and vertical rails. Read the question, try to get the diagram. Look at the magnetic field. One component is along negative z-axis, the other component is along negative y-axis. I'll get into the problem. So let this be.
Sir, it is minus by k cap or j cap, sir, in question.
Minus by, another is j cap. Some misprint occurred. I'll change it. This one you mean to say, this should be j cap. By j cap bz k cap. Yeah. Now this is a resistor R. Let L be the length of the rod and M is the mass of the rod, that also given, and also the gravity is also given for us. There's a friction between the rail and the rod. So it is like this. So here at this particular point, it will offer a friction. Let's begin with our problem. The Z component will produce magnetic field. Here I wrote XY coordinate. So plus Z axis will be somewhere in this direction. So therefore BZ will be into the plane. We have a practice of showing like this, no? So let's show BZ. What about BY? BY is Y component of field is in this direction. Now the rod is released. The weight mg will act. So due to weight mg, it will start sliding down. Then as it starts sliding down, flux linking the loop varies, and negative flux increases d phi by dt, negative EMF induced positive. So what direction the induced current should flow? The induced current should flow in anti-clockwise. Initially, this what happens at t equals 0, the rod is released from rest. And because of weight, it starts sliding down. As it starts sliding down, then the flux linking the loop varies. Then the induced current will flow anti-clockwise. Now, current carrying loop is there in a magnetic field. Let's see what are the forces that are acting. What are the forces that are acting? Now, due to BZ component, B bar I, so there should be a force, BL force. So this is like BZ I L. L is the length of the PQ equal to L, you take it. This is like a BL force, no, which will oppose that one. Next again, let's do BYI. How do it will act? B bar and current, no. So that particular BYIL will be pressing the rod against the rails. Look at the G in the problem. You have to be very careful that the G is indicated vertically down. So therefore, that BYIL will press the rod against the rails. And because of that, what happens? There'll be friction. So I think I'll give the only I'll show this. This will be force will be acting on the rod. How much it is? BZ. So BY IL, and it will be pressing the rod. and because of there'll be a normal contact, and F equal to mu n. I think I can help you with small diagram. Rest are supposed to imagine. Red color. I'll try to give the diagram. Okay, at P or Q, let me take anywhere at P or Q. So there's the rod, no? How BYL, it will be like this. BYIL will be like this. So the normal contact will be like this. The weight mg will be like this. So I next BZIL will be like this. How the friction should act? Friction should act upward, no? And what is F? F should be equal to first, what is N? Actually, the friction will act at both P and Q. I'm showing it only one point. Please do understand. So what is BYIL minus N equal to 0? Now this is what is the direction. Shall we put NZ? Normal reaction along the axis it is. At P or Q. At both the points with the act, I'm just showing the resultant. So then what is F? F should be equal to mu NZ. So frictional force equal to mu By I into L. Let's write the equation now. It will accelerate mg minus bz il minus f equal to me. What is that from Faraday's law? What is I? I equal to E by R, and this should be equal to BLV by R. Which B you should write? BY or BZ?
BZ.
BZ it should be, not BY. Or don't take resultant again. The rate of change of flux is due to Z component of the magnetic field. The resultant is what I'm showing. I can't draw so many diagrams. The resultant on the rod I'm showing, that's why I'm just so this better let me say rod. Is it okay? Fine. Instead of 2F, no, better you show that. It's only resultant. I'm just saying that red color is rod. Okay, now substitute all the things and go for calculation. BZ, this will be BZ LV LR minus mu BY this is mu By IL equal to Me. Let me substitute all the quantities here now. Bz, what is I? Bz LV by R, this is L. Mu By Bz square L square VR mu Bz By L square R. I think now you know integration. Apply that integration and try to solve. V you take common. And I think I'll leave the mathematics to students. Please do work out. So B square Bz square L square R plus mu Bz By L square R V equal to M dV by dt. Adjust all the things, you'll get expression again for V as a function of time, and that's what he's asking. Find the speed of the rod at time t.
Sir, frictional force will act at 2 points, no sir. 2F will not come, sir.
Oh my dear, resultant force. resultant force. BYL is what it will press it, no? It will press the rod against the rails at 2 points. That resultant is what I'm showing it.
Okay, sir.
Fine. So please go back to mechanics. You learned so many things. Please do apply, not learning and forgetting. Take next one. So if they don't mention anything in gravity, what does it mean? The weight will act perpendicular to plane of paper. You have to be very careful. Some students, I don't know what will happen for you in exam.